Close your eyes now. Let your body sink deeper into the softness beneath you. Tonight, we begin a gentle journey into one of the universe's most beautiful mysteries. A story about twins that have never met. A tale of perfect opposites dancing in the darkness of space. Imagine, if you will, the very first moment of everything. Not the moment you were born, or when the earth formed, but the instant when time itself began. In that first flash of creation, something remarkable happened. The universe didn't just make one kind of building block. It made two. For every tiny particle that would one day become part of you, another particle was born. This twin was identical in almost every way. The same size. The same weight. The same inner spinning motion. But it carried the opposite electrical charge. Where one was positive, the other was negative. Where one spun left, the other spun right. Scientists called this mysterious twin antimatter. It sounds like science fiction, doesn't it? But antimatter is as real as the blood flowing through your veins right now. As real as the air filling your lungs with each peaceful breath. Think of antimatter as the universe's perfect mirror. When you look in a mirror, you see yourself reversed. Your right hand appears to be your left hand. Your reflection moves when you move, but everything is flipped. Antimatter is like that reflection, but far more complete. It's not just visually opposite, it's opposite in every possible way that matter can be opposite. Every electron in your body has an antimatter twin called a positron. Every proton that makes up the atoms in your bones has an opposite called an antiproton. Even the tiny neutrons have their antimatter doubles called antineutrons. It's as if the universe created a complete second set of building blocks, identical yet perfectly reversed. But here's where the story becomes both beautiful and strange. These twins, matter and antimatter, cannot peacefully coexist. When they meet, something extraordinary happens. They don't bounce off each other like two balls colliding. They don't stick together like magnets. Instead, they embrace in the most complete way possible. In that embrace, both particles disappear entirely. They transform into pure energy, pure light racing away at the speed of thought. It's the most perfect transformation in nature. Nothing is wasted. Nothing is left behind. Just energy, spreading outward like ripples on a perfectly still pond. This process has a gentle name that doesn't hint at its profound nature, annihilation. But don't let the word frighten you. In the language of physics, annihilation simply means transformation. It's the universe's way of turning matter back into the energy from which it came. You might wonder why, if antimatter is everywhere in the universe, you don't see these flashes of light constantly around you. The answer is one of the cosmos's greatest puzzles. In our corner of the universe, antimatter is incredibly rare. It's like finding a single snowflake in a vast summer meadow. Scientists believe that in those first moments after creation, matter and antimatter existed in almost perfect balance. Almost. For reasons we don't fully understand, there was slightly more matter than antimatter. Just a tiny bit more. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. In the cosmic dance that followed, almost everything annihilated. Billions upon billions of matter and antimatter particles met and transformed into light. The universe blazed with energy. But when the dance was over, that tiny excess of matter remained. You are made from the survivors of that ancient cosmic ballet. Every atom in your body, every molecule that makes up your DNA, every calcium ion strengthening your bones, all of it comes from that slight imbalance in the very beginning. You are made of the universe's leftovers, and that makes you incredibly special. The antimatter that does exist in our universe today comes from special processes. High-energy cosmic rays from distant stars sometimes create tiny amounts when they crash into our atmosphere. Deep in space, the violent cores of galaxies produce antimatter in their spinning, magnetic storms. And here on Earth, scientists have learned to create small amounts in massive machines, particle by particle. But these amounts are vanishingly small. If you collected all the antimatter ever created by humans, it would weigh less than a paperclip. Yet even that tiny amount contains energy beyond imagination. The relationship between matter and energy, described by Einstein's famous equation, tells us that a small amount of mass can become an enormous amount of energy. This is why antimatter captures the imagination of scientists and dreamers alike. It represents the most efficient transformation possible, perfect conversion of matter into energy. No waste. No pollution. Just pure, clean energy spreading out like gentle light. As you lie here in the quiet darkness, photons of light are dancing around you. Some of them were born in the sun and traveled 93 million miles to reach your room. Others come from more distant stars, carrying messages from across the galaxy. And some, just some, might be the gentle remnants of matter and antimatter that found each other somewhere in the vast cosmos and transformed into light. The story of antimatter is ultimately a story about balance. About how the universe creates opposites that define each other. About how destruction and creation are simply different words for the same cosmic process. About how you, in all your complexity and wonder, exist because of the most delicate imbalance in the foundations of reality. Tonight, as sleep begins to call to you, know that you are connected to these cosmic processes in ways both subtle and profound. The very atoms that make up your body were forged in the hearts of ancient stars. The energy that powers your thoughts and dreams comes from processes that mirror the dance between matter and antimatter. But this is only the beginning of our gentle journey. Tomorrow night, we'll discover how scientists first glimpsed these invisible twins, hidden in trails of vapor that told stories of particles moving through space in ways that should have been impossible. Take a slow, deep breath. Feel the air fill your lungs completely, then watch as you exhale into the cool night air around you. If the air is cold enough, you can see your breath forming tiny clouds. Gentle wisps of vapor that appear for a moment, then fade away into the darkness. This simple act of breathing connects you to one of the most important discoveries in the history of science. Because it was in trails of vapor, much like your breath on a winter morning, that scientists first glimpsed the invisible world of antimatter. Picture a young man named Carl Anderson in 1932. He's working in a laboratory at the California Institute of Technology, surrounded by strange devices that hum and spark with electricity. Anderson is only 27 years old, about the same age as many graduate students today. He has curious eyes and patient hands, perfect for the delicate work of tracking invisible particles. Anderson's most important tool is something called a cloud chamber. Imagine a glass box filled with alcohol vapor, so pure and clean that it's like looking into the clearest mountain air. This vapor sits right on the edge of becoming visible. It wants to form droplets, like dew waiting to appear on morning grass, but it needs something to help it condense. When a charged particle zips through this waiting vapor, something magical happens. The particle leaves behind a trail of disturbed molecules, like a boat cutting through still water. These disturbed molecules give the vapor exactly what it needs to form tiny droplets. Suddenly, an invisible particle's path becomes visible as a delicate line of mist. Anderson places his cloud chamber between the poles of a powerful magnet. This magnetic field will bend the paths of charged particles, curving them like a river bending around a stone. Positive particles curve one way. Negative particles curve the other way. The amount of curve tells Anderson how much energy the particle carries. From high above, cosmic rays rain down constantly. These are particles born in the violent hearts of distant stars, accelerated to incredible speeds, then sent racing across the galaxy. Most pass through the Earth without leaving any trace. But some crash into Anderson's cloud chamber, painting their stories in trails of vapor. Day after day, Anderson photographs these delicate tracks. Each photograph captures the ghost-like signatures of particles too small to see. Most tracks curve exactly as expected. Electrons bend one way, their paths marking gentle arcs through the vapor. Other particles follow different curves, each telling its own story about mass and charge and speed. But then Anderson notices something strange. Among the many tracks in his photographs, some seem to be curving the wrong way. These mysterious tracks have the same gentle curve as an electron, suggesting they carry the same tiny mass. But they bend in the opposite direction. At first, Anderson thinks these must be electrons moving backward, somehow traveling from the bottom of his detector toward the top. But that doesn't make sense. The cosmic rays are coming from above, not below. These particles should be moving downward through his chamber. Anderson stares at photograph after photograph. The evidence is clear, but it challenges everything scientists think they know about matter. These tracks belong to particles that behave exactly like electrons in every way except one: they carry a positive charge instead of a negative one. Anderson calls these mysterious particles positrons. The name combines positive and electron, describing exactly what he's discovered: particles that are like electrons but with opposite charge. He doesn't realize it yet, but he's looking at humanity's first glimpse of antimatter. The discovery sends ripples through the scientific community like stones dropped into a quiet pond. A few years earlier, a brilliant physicist named Paul Dirac had written equations suggesting that every particle should have an opposite twin. Most scientists thought Dirac's math was elegant but probably not real. Anderson's photographs prove that Dirac's mathematics had been describing something true about the universe all along. Each photograph in Anderson's collection tells a story spanning millions of years. The cosmic ray that created each track began its journey in a distant star, perhaps in a galaxy so far away that its light takes millions of years to reach Earth. The particle traveled through the emptiness of space, carrying energy from that ancient stellar explosion. When the cosmic ray finally reaches Earth's atmosphere, it crashes into molecules of nitrogen and oxygen with tremendous force. In that collision, new particles are born, including the positrons that Anderson captures in his photographs. These antimatter particles exist for only the briefest moment before they find an electron and annihilate in a flash of gamma rays. But in that brief moment, some positrons make it into Anderson's cloud chamber. They leave their signatures in vapor trails, like signatures written in disappearing ink. Anderson's photographs preserve these fleeting moments, capturing proof of antimatter's existence in trails that fade away within seconds. The beauty of Anderson's discovery lies not just in what he found, but in how he found it. Using nothing more than alcohol vapor, a magnetic field, and careful observation, he revealed a fundamental truth about the universe. His cloud chamber was like a window into the invisible world, making the unseeable suddenly visible. Anderson's patient work reminds us that discovery often comes to those who pay attention to small details. Among hundreds of normal particle tracks, he noticed the few that were different. He didn't dismiss them as mistakes or equipment problems. Instead, he trusted his observations and followed them wherever they led. As you settle deeper into comfort tonight, think about the cosmic rays still falling gently around you. Right now, particles from distant stars are passing through your room, through your body, carrying stories of stellar explosions and galactic journeys. Most leave no trace of their passage. But some create brief flashes of light in the upper atmosphere, tiny auroras too faint for your eyes to see. Anderson's discovery changed forever how we understand the universe. He showed us that reality is richer and stranger than we had imagined. For every type of particle we know, there exists a mirror image waiting to be discovered. The universe is not just filled with matter, it's filled with antimatter twins, most of them so rare and fleeting that they vanish before we can study them. The photographs Anderson took in 1932 still exist today, carefully preserved in scientific archives. Those fading images of vapor trails represent one of humanity's first glimpses into the quantum world that surrounds us. They remind us that the most profound discoveries sometimes come from the simplest observations. Tonight, as you drift toward sleep, imagine Anderson in his laboratory, patient and curious, watching vapor trails appear and disappear like your breath in winter air. His discovery opened a door to understanding the cosmic dance between particles and their antimatter twins, a dance that shapes the very fabric of reality. But Anderson's positrons raised as many questions as they answered. If antimatter particles exist, why are they so rare? And what would happen if matter and antimatter actually met face to face, like long-lost twins finally finding each other in the cosmic dark? Let your body relax completely now. Feel yourself sinking deeper into comfort as we explore one of nature's most beautiful partnerships. Tonight, we discover what happens when particles meet their perfect opposites, like dancers who have been waiting across the cosmos to find each other. Imagine for a moment that somewhere in the universe, there exists another version of you. Not a twin with a different personality or life story, but something far more fundamental. This other you is made of the same patterns, the same arrangements of particles, but every single piece carries the opposite charge. Where your electrons spin with negative energy, your double's positrons spin with positive energy. Where your protons hold positive charges in their cores, your double's antiprotons carry negative charges. Every neutron in your bones has a corresponding antineutron in your double skeleton. You are perfect mirrors of each other at the most basic level possible. This isn't science fiction. This is the reality of antimatter that surrounds us every day. Every particle that makes up your body has an antimatter twin somewhere in the universe. These twins are identical in mass, identical in size, identical in every property except for the fundamental charges they carry. The electrons flowing through your nervous system right now each weigh exactly the same as their antimatter twins called positrons. If you could somehow place an electron and a positron on opposite sides of the most sensitive scale in the universe, the scale would balance perfectly. They are identical twins, born from the same quantum processes, but living in opposite electrical worlds. When an electron meets a positron, something extraordinary happens. They don't bounce off each other like two marbles colliding. They don't stick together like magnets finding their match. Instead, they perform the most complete dance possible in the universe. They embrace so perfectly that both partners disappear entirely. In that moment of contact, both particles transform into pure energy. The electron's mass becomes energy. The positron's mass becomes energy. Nothing is left behind except light racing away in all directions. It's the most efficient transformation known to science, complete conversion of matter into energy with absolutely no waste. This process follows Einstein's famous equation, the one you've probably seen written as E equals mc squared. The equation tells us that even tiny amounts of matter contain enormous amounts of energy. When matter and antimatter meet, the hidden energy is released all at once, like a flower blooming in fast motion. The light that emerges from this cosmic dance carries a special signature. Scientists call these light particles gamma rays, and they race away from the annihilation site at the speed of light itself. Each gamma ray carries exactly half the energy that was stored in the original matter-antimatter pair. It's nature's way of keeping perfect balance in the cosmic ledger. You can think of this process like two opposite waves meeting on a perfectly still pond. When the peak of one wave meets the valley of another wave of equal size, they cancel each other out completely. The water becomes perfectly flat again, but the energy that created those waves doesn't disappear, it spreads outward as gentle ripples in all directions. This dance between matter and antimatter happens around you more often than you might imagine. High in Earth's atmosphere, cosmic rays from distant stars create positrons that live for brief moments before finding electrons to dance with. In medical facilities, special machines create positrons on purpose, using them to create detailed pictures of the inside of human bodies. The beauty of annihilation lies in its completeness. When other types of particles interact, they usually create new particles or change their properties. But when matter meets antimatter, the transformation is total. Both particles give up their entire existence to become pure energy, like dancers spinning so fast they become light itself. Scientists have learned to create antimatter particles in laboratories, though only in incredibly tiny amounts. Creating even a single antiproton requires enormous machines and tremendous amounts of energy. The antiproton that emerges exists for only the briefest moment before it finds a regular proton and transforms into gamma rays. This scarcity of antimatter in our everyday world is part of what makes the universe so interesting. In the first moments after the Big Bang, matter and antimatter existed in almost equal amounts. They should have completely annihilated each other, leaving behind a universe of pure energy with no planets, no stars, and no you. But somehow, matter won by the tiniest margin. For every billion antimatter particles, there were 1,000,000,001 matter particles. When the great annihilation dance ended, that tiny excess of matter remained to build everything we see today. You exist because of the universe's most delicate imbalance. The antimatter particles that do exist in our universe today are like rare flowers blooming for just an instant before they fade. They appear in cosmic ray showers, in the hearts of stars, in the violent jets of energy that shoot from black holes. Most exist for less than a microsecond before they find a matter partner and transform into light. When you look up at the night sky, some of the starlight reaching your eyes was born from matter-antimatter annihilation in distant suns. The nuclear fires that power stars sometimes create small amounts of antimatter as a byproduct of their fusion reactions. These antimatter particles quickly find matter partners within the star's core, adding their energy to the stellar fire that has been burning for billions of years. Even in your own body, tiny amounts of antimatter appear and disappear constantly. The natural radioactivity in your bones sometimes creates positrons that live for nanoseconds before annihilating with nearby electrons. This process has been happening inside you since the day you were born, contributing in the smallest possible way to the warmth that keeps you alive. The dance between matter and antimatter reminds us that destruction and creation are often the same process viewed from different perspectives. When particles annihilate, they are not really destroyed, they're transformed into the purest form of energy possible. That energy goes on to power other processes, to become other forms of matter, to participate in the endless recycling of the cosmos. As you settle deeper into rest tonight, imagine the quantum dances happening all around you. In the walls of your room, cosmic rays occasionally create antimatter particles that briefly exist before finding their matter partners. In the distant stars visible through your window, matter and antimatter embrace in stellar cores, adding their light to the gentle glow that has traveled across space to reach you. The story of these cosmic twins teaches us about balance, about how opposites can complete each other so perfectly that they become something entirely new. In the quantum world, the most opposite things don't fight, they dance together until they become light itself. But this raises a profound question that has puzzled scientists for decades. If matter and antimatter were created in equal amounts at the beginning of time, why did matter survive to build the universe we know today? Close your eyes and travel back with me to the very beginning of everything. Not just your beginning, or Earth's beginning, but the first moment when time itself started ticking. In that instant, smaller than the smallest fraction of a second you can imagine, the universe was born in a burst of energy so pure and bright that it contained no matter at all. But energy cannot stay as pure light forever. Like water cooling into ice, that primordial energy began to condense into particles. And when it did, something beautiful and mysterious happened. The universe didn't create just one type of building block. It created perfect pairs, matter and antimatter in exactly equal amounts. Imagine the early universe as a cosmic dance floor, filled with billions upon billions of dancing pairs. Each electron spun with its positron partner. Each proton twirled with its antiproton. Each neutron moved in perfect harmony with its antineutron twin. The dance floor pulsed with energy as these cosmic partners embraced and transformed into light, only for new pairs to emerge from that same light and begin dancing again. This was the universe's first and greatest performance, a ballet of creation and annihilation that should have lasted forever. Matter and antimatter, perfectly balanced, constantly transforming back and forth between particles and pure energy. If this balance had remained perfect, there would be no stars today. No planets. No oceans. No forests. No you. But something extraordinary happened in those first few moments. Something so subtle that scientists are still trying to understand it completely. The universe developed the tiniest preference for matter over antimatter. Not a strong preference, just the smallest possible tilt toward one side of the cosmic balance. Picture a scale so sensitive it can weigh individual atoms. On one side, place 1 billion antimatter particles. On the other side, place 1,000,000,001 matter particles. That single extra particle represents the imbalance that saved the universe from vanishing into pure light. For every billion dancing pairs that found each other and transformed into energy, one lonely matter particle was left without a partner. These cosmic wallflowers, abandoned on the dance floor, became the seeds of everything we see today. As the universe cooled and expanded, the great annihilation dance gradually ended. Most matter and antimatter had found their partners and become light. But those leftover particles, 1 out of every billion, remained behind like the last dancers when the music stops. These survivors had no antimatter partners to dance with, so they began to build instead of destroy. You are made from these survivors. Every atom in your body, every molecule in your DNA, every calcium ion in your bones descends from particles that outlasted the universe's greatest vanishing act. You exist because of the most delicate cosmic accident, a 1,000,000,000 lottery that matter managed to win. Scientists call this tiny imbalance matter-antimatter asymmetry, but that formal name doesn't capture the profound mystery it represents. Why did the universe choose matter over antimatter? What tipped the cosmic scales by that crucial single particle out of every billion? Some theories suggest that in the extreme conditions of the early universe, certain rare particle interactions slightly favored the creation of matter over antimatter. Like a coin that's weighted so slightly that it lands heads just a tiny bit more often than tails, these processes might have gradually built up the small advantage that matter needed to survive. Other scientists wonder if antimatter might have different properties than matter in ways we haven't discovered yet. Perhaps antimatter experiences gravity slightly differently, or interacts with space and time in subtly different ways. These tiny differences might have given matter just enough advantage to outlast its antimatter twins. The truth is, we still don't fully understand why you exist. The fact that you're lying here right now, breathing and thinking and listening to this story, represents one of the deepest unsolved mysteries in science. Your existence is evidence of a cosmic event so improbable that it challenges our understanding of how the universe works. Think about the incredible odds you've overcome just by being here. Not just the biological odds of your parents meeting, or your DNA arranging itself in exactly the right way, but the fundamental cosmic odds that any matter exists at all. You are the descendant of particles that won a lottery with odds of 1,000,000,000 to 1. This perspective makes every breath you take seem miraculous. The oxygen entering your lungs right now is made from atoms that survived the universe's greatest vanishing act. The carbon in your muscles, the iron in your blood, the calcium in your teeth, all of it exists because of that tiny cosmic imbalance 13 billion years ago. The antimatter that lost the cosmic lottery didn't disappear forever. It transformed into the light that filled the early universe, contributing to the cosmic background radiation that still bathes space today. In a sense, the losing antimatter became the universe's first sunrise, creating the gentle glow that warmed the cosmos as the first atoms began to form. Even today, that ancient dance continues in smaller ways throughout the universe. In the cores of stars, matter and antimatter still create and annihilate each other, adding their energy to the nuclear fires that light up the night sky. In cosmic ray showers high above your head, new matter-antimatter pairs briefly appear before dancing their ancient dance of transformation. The imbalance that created you also created everything else you can see when you look up at the stars. Every galaxy spinning in the cosmic dark, every nebula glowing with the light of newborn suns, every planet orbiting every star, all of it exists because matter won that ancient cosmic lottery by the smallest possible margin. Scientists estimate that the observable universe contains about 10 to the power of 80 particles. That's more particles than there are grains of sand on every beach on Earth, multiplied by billions upon billions. Every single one of those particles is a descendant of the lucky few that survived the Great Annihilation. As you settle deeper into comfort tonight, marvel at the incredible journey that brought you here. You are not just made of atoms forged in the hearts of ancient stars. You are made of atoms that survived the universe's first and greatest test, the cosmic dance between existence and nothingness. The universe could have chosen perfect symmetry, perfect balance, perfect annihilation. Instead, it chose to exist, to build, to create complexity and beauty and consciousness. It chose to create you. This ancient victory of matter over antimatter set the stage for everything that followed. But winning the cosmic lottery was just the beginning. The surviving matter particles still needed to find ways to stick together, to build atoms and molecules and eventually the complex structures that could support life. But that is a story for another time. Tonight, rest in the knowledge that your very existence represents the universe's triumph over nothingness, a testament to the power of the smallest imbalances to create the most magnificent outcomes. In laboratories around the world today, scientists are working to recreate tiny amounts of antimatter, hoping to solve the mystery of why matter survived when antimatter vanished into light. Picture yourself walking through a quiet Swiss valley on a summer evening. The mountains rise gently around you, their peaks catching the last golden light of day. Beneath your feet, hidden far underground, one of humanity's most ambitious experiments unfolds in perfect silence. Deep below the peaceful countryside lies CERN, the European Organization for Nuclear Research. Here, in tunnels carved through solid rock, scientists work with tools that seem borrowed from dreams. They have learned to catch particles of antimatter and hold them suspended in space, like capturing individual fireflies in jars made of pure magnetism. The challenge they face would make ancient alchemists weep with envy. How do you hold something that cannot touch any container? How do you study particles that vanish the instant they contact ordinary matter? How do you preserve something more precious than the rarest diamond, yet more fragile than morning dew? The answer lies in fields you cannot see or touch, magnetic forces so precisely controlled they can cradle a single antiproton for hours, days, even weeks. These invisible cages are stronger than any material prison, yet gentler than the softest touch. Creating antimatter requires enormous machines that stretch for miles beneath the European countryside. Scientists accelerate protons to nearly the speed of light, then crash them into metal targets with tremendous force. In those violent collisions, energy transforms into matter and antimatter pairs, just as it did in the first moments after the Big Bang. But these newborn antiprotons emerge traveling at incredible speeds, far too fast and energetic to capture. Scientists must slow them down gradually, like taming wild horses one gentle step at a time. They use electric fields to break the antiprotons, cooling them from billions of degrees to just a few degrees above absolute zero. Even then, the antiprotons remain dangerous. A single touch against the walls of any container would cause instant annihilation. So scientists create containers made of nothing but magnetic force, invisible bottles that can hold antimatter suspended in perfect vacuum, never allowing it to touch any surface. These magnetic bottles are marvels of precision engineering. The magnetic fields must be perfectly shaped and incredibly stable. If the field wavers even slightly, the precious antiprotons escape and vanish in flashes of gamma rays. It's like balancing soap bubbles on the tip of a needle while riding a bicycle, requiring patience, skill, and extraordinary delicacy. The amounts of antimatter that scientists can create and store are almost impossibly small. All the antimatter ever produced by humanity would weigh less than a paperclip. If you could somehow collect every antiproton ever captured at CERN, they would be invisible to your naked eye, are just a few trillion particles floating in their magnetic prison. Yet these tiny amounts represent tremendous achievement. Each antiproton costs more to create than its weight in diamonds. The energy required to make a single gram of antimatter would equal the output of several nuclear power plants running for years. It's the most expensive substance ever created by human hands. Why go to such extraordinary lengths to study something so rare and costly? Because antimatter holds keys to some of the universe's deepest mysteries. By comparing how matter and antimatter behave, scientists hope to understand why the universe chose existence over nothingness billions of years ago. In their underground laboratories, researchers perform the most delicate experiments imaginable. They study how antiprotons respond to gravity, wondering if antimatter might fall upward instead of down. They examine how antimatter interacts with light, searching for tiny differences that might explain the cosmic imbalance that created our world. Some experiments involve creating antiatoms, complete antimatter versions of hydrogen, the simplest and most common element in the universe. These antiatoms consist of a single antiproton orbited by a single positron, perfect mirror images of ordinary hydrogen atoms. Scientists can hold dozens of these antiatoms suspended in their magnetic traps, studying how they absorb and emit light. The precision required for these experiments stretches human ingenuity to its limits. Scientists must control temperatures to within thousandths of a degree, maintain vacuum conditions cleaner than outer space, and create magnetic fields stable to 1 part in a billion. Any vibration, any electrical interference, any imperfection can destroy hours or days of careful work. Working with antimatter is like being a cosmic jeweler, crafting with materials so precious that every particle must be accounted for. Scientists track individual antiprotons the way a master goldsmith tracks individual gems. Each one represents months of preparation and enormous expense. The magnetic traps themselves are works of art as much as science. Invisible to the eye, they exist as perfectly shaped fields of force, sculpted from electricity and magnetism with mathematical precision. These fields can hold antimatter for weeks at a time, protecting it from any contact with the ordinary matter world. Sometimes the antiprotons escape their magnetic prison and annihilate against the trap walls. When this happens, sensitive detectors record the flash of gamma rays, allowing scientists to study even the moment of annihilation. These brief bursts of pure energy carry information about the fundamental nature of matter and antimatter. The researchers who work with antimatter develop an almost mystical relationship with their invisible charges. They speak of their antiprotons with the affection usually reserved for pets or garden plants. Each particle has been coaxed into existence through enormous effort and must be tended with constant care. As you rest tonight, imagine these dedicated scientists working through the quiet hours in their underground laboratories. Their instruments hum softly in the darkness, maintaining perfect conditions for particles that exist at the very edge of possibility. Magnetic fields as smooth as silk hold prisoners more precious than any treasure. The antimatter floating in those invisible bottles connects us to the fundamental forces that shape the cosmos. Each antiproton carries within it the memory of the universe's first moments, when matter and antimatter dance together in perfect balance before somehow choosing different fates. These captive particles represent humanity's attempt to understand our own existence at the deepest possible level. By learning to create and control antimatter, we're essentially having a conversation with the universe about why we're here at all. The work continues around the clock, as patient as monks tending a sacred flame. Each day brings new insights into the nature of these mirror particles that hold such power locked within their tiny forms. But understanding antimatter's behavior in the laboratory is only part of the story. The real wonder lies in discovering what happens when this perfect efficiency of matter-antimatter annihilation is unleashed, and whether such power could ever be harnessed for humanity's benefit. Settle into the quiet comfort around you and imagine the perfect energy source. No smoke rising into the sky. No ash left behind. No radioactive waste to store for thousands of years. Just complete transformation of matter into pure, clean energy, as gentle and efficient as sunlight itself. This is the promise of antimatter, nature's most perfect fuel. When a particle of matter meets its antimatter twin, both disappear entirely, transformed into light that races away at 300 million meters per second. It's the cleanest reaction possible, leaving behind nothing but energy in its purest form. Think about the fuels that power our world today. When wood burns in a fireplace, only a tiny fraction of its mass becomes energy. Most remains as ash and smoke, drifting away as heat and gases. Even our most efficient power plants convert less than half of their fuel into useful energy. The rest becomes waste heat that warms the rivers and atmosphere. But antimatter is different. When matter and antimatter meet, 100% of their mass becomes energy. Not 90%. Not 99%. Every single atom transforms completely, following Einstein's equation with perfect mathematical precision. It's efficiency that approaches the theoretical limits of what's possible in our universe. A single gram of antimatter, if it could meet a gram of ordinary matter, would release as much energy as exploding 25,000 tons of dynamite. That's roughly the same energy that powers a large city for several hours, all contained in an amount of antimatter smaller than a paperclip. To put this in perspective, imagine powering your entire home for thousands of years with an amount of fuel so small you couldn't see it with your naked eye. The lights in your room, the warmth that keeps you comfortable, the electricity that charges your devices, all of it could come from antimatter particles too tiny to cast a shadow. This incredible energy density makes antimatter the ultimate rocket fuel. Chemical rockets, like those that carried astronauts to the moon, can only accelerate to about 17,000 miles per hour. They burn heavy fuel and carry massive tanks, most of their energy spent just lifting their own weight against Earth's gravity. An antimatter rocket would be completely different. The fuel would weigh almost nothing. The exhaust would be pure light, pushing the spacecraft forward at speeds approaching the velocity of light itself. A journey to Mars that now takes 9 months might be completed in just a few weeks. But here lies one of the universe's most beautiful paradoxes. Creating antimatter requires far more energy than it can ever give back. It's like trying to fill a bucket by carrying water in a sieve. Most of your effort is wasted before you accomplish anything useful. The particle accelerators at CERN that create antimatter consume enormous amounts of electricity. They use as much power as a small city running day and night to produce amounts of antimatter so tiny they're measured in individual particles. Creating just 1 gram of antimatter would require more energy than the entire world produces in a year. Scientists estimate that making antimatter fuel costs about $100 trillion per gram. That's more expensive than any substance that has ever existed. A single antiproton costs more to create than its weight in the most precious diamonds, yet it vanishes instantly if it touches anything made of ordinary matter. This creates a fascinating engineering challenge. How do you store the most powerful fuel imaginable when it cannot touch any container? How do you transport something that costs more than entire countries yet weighs less than a feather? How do you control reactions so energetic they could power cities yet so delicate they can be disrupted by the smallest vibration? The answers lie in the same magnetic bottle technology used in research laboratories. Spacecraft of the future might carry tiny amounts of antimatter suspended in magnetic fields, never touching any solid surface. These fuel tanks would be invisible, just precisely shaped fields of force containing more energy than chemical rockets could carry in massive fuel compartments. Using antimatter fuel would require extraordinary precision. Unlike gasoline engines that can run roughly and still function, antimatter systems would demand perfect control. Too little fuel, and your spacecraft drifts powerless through space. Too much, and the release of energy could vaporize your entire ship in a flash of gamma rays. Yet the potential rewards make these challenges seem worthwhile. Antimatter propulsion could open the solar system to human exploration in ways we can barely imagine. Jupiter, which now takes years to reach, might become a destination for week-long journeys. The moons of Saturn could be as accessible as distant continents once were to sailing ships. Even closer to home, antimatter's perfect efficiency could revolutionize how we generate electricity. A single antimatter power plant, no larger than a city block, could supply clean energy to millions of homes. No pollution would enter the atmosphere. No radioactive waste would require long-term storage. Just pure energy conversion with mathematical perfection. The waste heat from such a plant would be minimal compared to today's power stations. The cooling towers that characterize nuclear plants would be unnecessary. The mountains of coal that feed power stations would become relics of a less efficient age. The atmosphere would slowly clear as humanity learned to harness the same process that powers the creation of elements in stellar cores. But perhaps the most beautiful aspect of antimatter fuel lies not in its practical applications, but in what it represents about the nature of matter itself. Every particle in your body contains enormous amounts of energy, locked away in the very structure of atoms. Einstein's equation tells us that matter and energy are simply different forms of the same fundamental thing. When you touch the wall beside you, you're touching stored sunlight. The atoms in that wall were forged in ancient stars, their bonds holding energy that has been waiting billions of years to be released. Antimatter offers a way to unlock that energy completely, transforming matter back into the light from which it originally came. As you rest tonight, consider the extraordinary potential sleeping within ordinary matter. The pillow beneath your head contains enough locked energy to power your dreams for millions of years, if only we had the antimatter keys to unlock it. Every breath you take brings atoms into your lungs that could, in principle, power cities if they could dance with their antimatter twins. The challenge of creating antimatter fuel reminds us that the universe rarely gives up its greatest treasures easily. The most powerful forces require the most careful understanding, the most patient research, the most respectful approach to the fundamental laws that govern reality. But antimatter's promise extends far beyond powering rockets or generating electricity. In the hands of doctors and medical researchers, these mirror particles are already saving lives in ways both gentle and profound. Let your breath flow gently and naturally as we step into a quieter story tonight. In hospitals around the world, while patients rest and heal, antimatter particles move silently through human bodies like gentle messengers of light. These invisible healers carry no harm, only information that helps doctors see what cannot be seen. Picture a hospital room bathed in soft morning light. A patient lies peacefully on a scanning table, unaware that antimatter, those same mirror particles we've been exploring, are about to travel through their body. But these aren't the powerful antimatter particles that could fuel starships. These are gentler cousins, created for healing rather than power. The antimatter used in medicine comes from special atoms called radioisotopes. These are like ordinary atoms that have learned to glow, releasing tiny amounts of energy in the form of positrons, the antimatter twins of electrons. Scientists have learned to create these glowing atoms in ways that make them perfectly safe for the human body. One of the most common medical radioisotopes is called fluorine-18. It's created in machines called cyclotrons, which spin particles around in circles until they gain just the right amount of energy. When fluorine-18 is born, it carries within itself a kind of gentle restlessness. It wants to transform, to find balance, and it does this by releasing positrons into the world. These positrons live for just moments before they find electrons to dance with. But in those brief moments, they create flashes of light that special cameras can detect. It's like having fireflies that glow inside your body, showing doctors exactly where they've traveled and what they've seen. The process begins when doctors attach the fluorine-18 to a special kind of sugar. Your body loves sugar and draws it into your cells like a magnet attracting iron filings. The most active parts of your body, your brain when you're thinking, your heart when it's working hard, areas where cells are growing quickly, these places consume the most sugar. As the radioactive sugar flows through your bloodstream, it travels to every corner of your body. The fluorine-18 continues its gentle decay, releasing positrons that immediately begin their brief journey through your tissues. Each positron travels only a tiny distance, less than the width of a few cells, before it encounters an electron. When positron meets electron, they perform their ancient dance of annihilation. But instead of releasing the enormous energies we've discussed before, these medical interactions are perfectly sized for human bodies. The gamma rays they produce are gentle enough to pass harmlessly through your tissues, yet energetic enough to be detected by sensitive cameras surrounding you. The scanning machine, called a PET scanner, stands for positron emission tomography. It's a ring of detectors that can pinpoint exactly where each antimatter annihilation occurs inside your body. The machine listens for the twin gamma rays that race away from each annihilation, using them to create a map of where the radioactive sugar has traveled. The beauty of this process lies in its gentleness. You feel nothing as the positrons move through you. There's no sensation as they meet electrons and transform into light. The amount of antimatter in your body during the scan is incredibly small, far less than the natural radioactivity already present in your bones and tissues. What emerges from this invisible dance is something miraculous, a three-dimensional picture of your body's activity. Doctors can see which parts of your brain are working hardest when you think about someone you love. They can watch your heart muscle as it pumps, identifying areas that might need extra care. They can spot collections of cells that are growing too quickly, catching problems before they become serious. The images created by PET scans look like glowing landscapes of the human body. Active areas shine brightly where the radioactive sugar has gathered. Quiet areas appear dimmer. It's as if your body has been painted with gentle light from within, revealing its secrets through the soft glow of antimatter transformations. This medical use of antimatter represents one of humanity's most benevolent applications of these mysterious particles. Instead of harnessing their power for energy or propulsion, we've learned to use their perfect transformation as a tool for healing. The same process that could theoretically power spacecraft becomes a gentle way to peer inside the human body. Thousands of people receive PET scans every day around the world. Cancer patients, heart disease sufferers, people with neurological conditions, all benefit from these antimatter messengers that briefly inhabit their bodies. The positrons created for these scans exist for mere minutes before they complete their purpose and vanish into light. The radioisotopes used in medical imaging must be created fresh, like flowers that bloom and fade quickly. The fluorine-18 used in most PET scans has a half-life of about 2 hours, meaning that half of it transforms into harmless, stable atoms every 2 hours. By the next day, virtually all of it has completed its transformation and disappeared. This short lifetime means that hospitals with PET scanners often have their own cyclotrons, creating fresh batches of medical antimatter throughout the day. It's like having a bakery that produces healing light instead of bread, creating exactly what's needed when it's needed and allowing it to fade away naturally. The doctors and technicians who work with medical antimatter develop a profound appreciation for these invisible healers. They understand that they're working with particles that represent the fundamental forces of creation and annihilation, but applied with such precision that they become tools of compassion rather than power. As patients move through PET scanners, they become temporary hosts to antimatter particles that have traveled from the quantum realm into the realm of human healing. These positrons carry no memory of the cosmic processes that created their kind, no awareness of their role in the universe's grand story. They simply fulfill their purpose, to transform and, in transforming, to heal. The images produced by these antimatter interactions often reveal problems long before patients feel any symptoms. A small collection of overactive cells might show up as a bright spot on a scan, allowing doctors to begin treatment while the body is still strong. It's early warning provided by particles that exist at the very edge between matter and energy. Tonight, as you settle into rest, know that in hospitals around the world, antimatter particles are quietly working to save lives. They move through human bodies like gentle spirits, carrying information instead of destruction, healing instead of harm. But these medical positrons represent only the tiniest fraction of the antimatter that surrounds us every day, falling gently from space in an invisible rain that connects us to the most distant corners of the universe. Close your eyes and imagine looking up at the night sky above you. Beyond the gentle darkness, beyond the twinkling stars you can see, an invisible shower falls constantly toward Earth. These are cosmic rays, particles that began their journey in the violent hearts of distant suns, traveling across the galaxy to find you here in your quiet moment of rest. Right now, as you breathe slowly and peacefully, these cosmic messengers are arriving from space at the speed of light. Most are protons, the same particles that form the cores of hydrogen atoms. Others are heavier atomic nuclei, stripped of their electrons during cosmic catastrophes billions of years ago. All carry enormous energy from their long journey through the void between stars. When these cosmic travelers reach Earth's atmosphere, something beautiful happens. They crash into molecules of nitrogen and oxygen with tremendous force, like cosmic raindrops hitting an invisible pond. In those collisions, the energy of their long journey transforms into showers of new particles, including the antimatter twins we've been learning about. High above your head, perhaps 15 miles up where the air becomes thin and cold, cosmic ray collisions create brief flashes of positrons. These antimatter particles appear for just moments, born from the impact of starlight that has traveled for thousands of years to reach our small planet. Most exist for less than a microsecond before they find electrons and transform into gentle gamma rays. But some of these cosmic antimatter particles survive their brief journey toward Earth. They drift downward through the thinning atmosphere, invisible and weightless, carried by air currents like seeds from a cosmic dandelion. A few might even reach the ground, though most complete their dance with matter somewhere in the miles of air above you. This cosmic antimatter shower has been falling on Earth for billions of years. It fell on the first forests, on the earliest oceans, on the dinosaurs as they walked through ancient landscapes. It falls on cities and farms, on mountains and valleys, on every person who has ever looked up at the stars and wondered about their place in the universe. The amount of cosmic antimatter reaching you is incredibly small, just a few particles per second passing through your entire body. You feel nothing as they arrive and nothing as they annihilate with electrons in your tissues. These cosmic visitors are so gentle that they leave no trace of their passage except for the tiniest flashes of light that fade instantly into the quantum background of existence. Yet in that gentleness lies something profound. Every cosmic ray that creates antimatter in Earth's atmosphere began its journey in a stellar explosion somewhere in the galaxy. The supernova that launched the proton now creating a positron above your head might have occurred when Earth was still a ball of molten rock, billions of years before the first signs of life appeared. Think about the incredible journey these particles have taken to reach you. They were born in the nuclear furnace of a dying star, accelerated to nearly the speed of light by magnetic fields stronger than anything we can create on Earth. They traveled through the cold emptiness between solar systems, past planets and moons and asteroid belts, carrying their cargo of energy across distances so vast that light itself takes years to traverse them. Some cosmic rays come from our own sun, created in the magnetic storms that periodically erupt from its surface. Others arrive from the center of our galaxy, where a massive black hole accelerates particles to incredible energies. The most energetic cosmic rays might come from other galaxies entirely, carrying messages from cosmic events so distant that their light has not yet had time to reach us. When these ancient travelers finally encounter Earth's atmosphere, they don't simply bounce off or get absorbed. Instead, they share their energy in a cascade of creation, producing not just antimatter but dozens of other exotic particles that exist for brief moments before decaying into more familiar forms of matter and energy. Scientists study these cosmic ray showers using detectors spread across mountaintops and even buried deep underground. They can track the paths of particles created miles above, watching as the energy from a single cosmic ray spreads into a shower that might cover several square miles of Earth's surface. It's like watching fireworks in slow motion, each explosion creating dozens of smaller sparks that illuminate the invisible processes happening all around us. The cosmic rays that create antimatter above you right now connect you to some of the most violent and energetic processes in the universe. The same stellar explosions that can be seen from billions of light years away are gently touching your body through their antimatter messengers. You are, in the most literal sense, being caressed by starlight that has traveled across the cosmos to find you. This cosmic antimatter rain varies with the seasons and even with the 11-year cycle of solar activity. When the sun is most active, its magnetic field deflects some cosmic rays away from Earth, reducing the antimatter shower slightly. When the sun is quiet, more cosmic rays penetrate to our atmosphere, creating more positrons in the air above you. Even the room you're resting in right now is gently radioactive from cosmic ray interactions. The walls around you contain tiny amounts of radioactive carbon-14, created when cosmic rays interact with nitrogen in the atmosphere. This carbon-14 eventually makes its way into all living things, including the wood in your furniture and even the cells in your body. You are, quite literally, made partly from cosmic ray interactions. The cosmic antimatter falling around you represents just one small part of the vast recycling system that connects all matter in the universe. The same processes that create positrons in Earth's atmosphere also create the elements necessary for life, the energy that powers stellar evolution, and the complex chemistry that allows planets to form and evolve. As you settle deeper into rest tonight, imagine this gentle cosmic rain continuing to fall through the darkness above you. Particles born in stellar explosions millions of years ago are completing their long journey, creating brief flashes of antimatter that connect your quiet moment to the most energetic events in the cosmos. Each breath you take brings cosmic ray particles into your lungs, not the original high-energy particles, but the gentler products of their atmospheric interactions. The oxygen you breathe was created in ancient stars and delivered to Earth by the same cosmic processes that now create antimatter showers above your head. This invisible connection between your peaceful rest and the violent beauty of stellar death and birth reminds us that we are never truly separate from the cosmos. The universe expresses itself through processes both gentle and powerful, from the quiet transformation of antimatter in your body to the spectacular explosions that launch cosmic rays across the galaxy. But among all the cosmic antimatter created in Earth's atmosphere, some interactions are so energetic that they produce not just individual particles, but enough antimatter to power the most ambitious dreams of human exploration and discovery. Take a slow, peaceful breath and let your mind drift toward something remarkable. In the palm of your hand, you could hold an amount of antimatter smaller than a sugar cube. This tiny amount would contain more energy than has ever been released at once in human history. Yet this power follows the same gentle law that makes stars shine and flowers grow. The scale of antimatter's energy is almost impossible to imagine using everyday comparisons. A single gram of antimatter, meeting its gram of matter twin, would release as much energy as a hurricane carries in its winds. It's the same energy that flows through the largest rivers on Earth for an entire day. All of this power contained in something lighter than a butterfly's wing. But numbers alone cannot capture the profound beauty of this transformation. When matter and antimatter meet, they don't simply explode like conventional fuels. Instead, they perform the universe's most complete dance, disappearing entirely into pure light. Every atom becomes energy. Every particle transforms into photons racing away at the speed of dreams. This process follows Einstein's famous equation, E=mc². The same gentle mathematics that describes how the sun converts hydrogen into helium also governs what happens when your hand would meet its antimatter twin. Energy equals mass times the speed of light, multiplied by itself. It's a simple equation that reveals the enormous energy sleeping within the most ordinary matter. Think about the pencil beside your bed, or the glass of water on your nightstand. These familiar objects contain vast amounts of energy locked away in their atomic structure. If they could somehow meet their antimatter twins, they would transform into more energy than a small town uses in a year. The energy was always there, hidden in the bonds between particles, waiting for the perfect key to unlock it. The sun demonstrates this same principle every second of every day. Deep in its core, hydrogen atoms fuse together to become helium, converting a tiny fraction of their mass into the light that warms your face. But even the sun's nuclear fusion is less efficient than antimatter annihilation. The sun transforms less than 1% of its fuel's mass into energy. Antimatter converts 100%. If the sun could somehow use antimatter fuel instead of hydrogen fusion, it would shine just as brightly while consuming matter at a rate millions of times slower. A sun powered by antimatter would burn for trillions of years instead of billions, providing steady warmth to its planets across cosmic ages almost too long to contemplate. The largest bombs ever created by humans release energy by splitting heavy atoms apart or forcing light atoms together. These nuclear reactions convert less than 1% of the atom's mass into energy. The rest remains as radioactive fragments that must be carefully contained for thousands of years. It's powerful, but wasteful, like burning a library to feel the heat from just a few pages. Antimatter annihilation is different. It's like every book in the library transforming simultaneously into pure, warm light. Nothing remains behind. No radioactive waste. No toxic fragments. No pollution of any kind. Just energy in its most fundamental form, spreading outward as gentle photons that carry no harmful radiation. This completeness of transformation makes antimatter both incredibly powerful and strangely peaceful. The gamma rays produced by matter-antimatter annihilation are energetic, but they're also clean. They don't contaminate their surroundings or leave behind dangerous residues. They simply carry energy away from the annihilation site, eventually losing their intensity as they spread through space. Scientists who study antimatter often speak of this process with something approaching reverence. They're witnessing matter return to its most basic form, pure energy traveling at light speed. It's the reverse of the process that created matter in the first place, when energy from the Big Bang condensed into the first particles billions of years ago. The energy scale of antimatter helps explain why it remains so rare in our everyday world. If significant amounts of antimatter existed naturally on Earth, the energy releases from accidental contacts with ordinary matter would reshape landscapes. Mountains would become valleys. Oceans would flash into steam. The delicate chemistry that supports life would be impossible. Instead, the universe has arranged itself so that antimatter appears only in tiny amounts, usually in places far from complex structures like planets and living things. The cosmic ray antimatter falling gently around you right now exists in such small quantities that its annihilations produce only the faintest flickers of light, barely detectable even with the most sensitive instruments. Yet even these tiny amounts remind us of the enormous energies locked within ordinary matter. Every breath you take brings atoms into your body that contain more energy than the most powerful engines. That energy remains safely locked away, accessible only through the most complete transformation possible, our meeting with antimatter twins. This hidden energy connects you to the fundamental forces that shape the universe. The same equation that governs antimatter annihilation also explains how stars forge heavy elements in their cores, how black holes convert matter into the jets of energy that light up entire galaxies, and how the expansion of space itself draws energy from the quantum fields that fill the void. Understanding antimatter's energy scale helps us appreciate both the power and the fragility of our world. We live in a universe where tremendous energies flow through processes both violent and gentle, from stellar explosions that can be seen across billions of light-years to the quiet radioactive decay happening in the atoms of your own body. The fact that you can rest peacefully tonight, surrounded by matter but not antimatter, represents one of the fundamental asymmetries that make complex structures possible. If matter and antimatter existed in equal amounts throughout the universe, the constant annihilations would fill space with so much energy that atoms couldn't form stable bonds, molecules couldn't develop complex shapes, and life couldn't begin its patient work of organization and growth. As you settle deeper into comfort, consider the delicate balance that allows your existence. You live in a universe powerful enough to convert matter entirely into energy, yet stable enough to let that matter organize itself into planets, trees, and conscious minds that can contemplate their own atomic structure. The energy contained in antimatter represents both what we might become and what we've moved beyond. It's the power source of theoretical starships and the driving force behind cosmic evolution. It's the ultimate fuel and the fundamental process that created the elements of which you're made. Tonight, as sleep begins to call to you, know that the same forces capable of releasing unimaginable energy are also responsible for the gentle processes that sustain your life. The weak nuclear force that allows antimatter to be created also governs the radioactive decay that warms Earth's core. The electromagnetic force that guides matter-antimatter annihilation also holds your DNA together and carries the signals through your nervous system. But harnessing such enormous energies requires technology and understanding that push the limits of human ingenuity, creating machines that seem borrowed from dreams of distant futures. Let your breathing slow and deepen as we explore humanity's most ambitious engineering dreams. Deep beneath the peaceful Swiss countryside, machines stretch for miles through underground tunnels, pursuing particles smaller than atoms with the dedication of master craftsmen. These are the cathedrals of modern science, built to capture and hold the most elusive substances in the universe. Picture the Large Hadron Collider, a ring of superconducting magnets 27 kilometers around. That's larger than many cities, yet its purpose is to study things far too small for any microscope to see. Inside this enormous circle, protons race through vacuum chambers at 99.9% of light speed, guided by magnetic fields stronger than Earth's own. These particles travel their circular path 11,000 times every second. In a single second, a proton in the collider covers a distance equal to traveling around Earth's equator nearly 3 times. Yet scientists control these incredible speeds with precision measured in fractions smaller than the width of a human hair. When 2 of these racing protons finally collide, they release more energy than existed in their masses alone. That extra energy, borrowed from their tremendous speed, transforms into new particles that exist for only the briefest moments. Among these newborn particles are antiprotons, antimatter twins of the protons that created them. But creating antimatter is only the first challenge. These antiprotons emerge from their collisions traveling at incredible speeds, far too fast and energetic to capture. Scientists must slow them down gradually, using electric fields like gentle brakes that can stop particles moving at nearly light speed without destroying them. The process requires extraordinary patience. Each antiproton must be cooled from billions of degrees to just a few degrees above absolute zero. This cooling doesn't happen with ice or refrigerators, but through careful manipulation of electric and magnetic fields that steal energy from the particles bit by bit, like a cosmic game of slow motion. Once cooled, the antiprotons face their greatest challenge, finding a home that will never touch them. Any contact with ordinary matter means instant annihilation. So scientists create containers made of pure magnetism, invisible bottles that can hold antimatter suspended in perfect emptiness, floating like captured stars in chambers emptier than outer space. These magnetic bottles are marvels of precision engineering. The magnetic fields must be shaped exactly right, too weak, and the antiprotons escape, too strong or uneven, and they crash into the walls and vanish in flashes of gamma rays. It's like balancing soap bubbles on invisible threads while riding a bicycle through an earthquake. The vacuum chambers that house these magnetic bottles are cleaner than any environment found naturally in the universe. Even the space between distant galaxies contains more stray atoms than these antimatter storage vessels. Scientists must pump out every molecule of air, every trace of water vapor, every particle of dust that might contaminate their precious antimatter. Working with these machines requires teams of hundreds of scientists and engineers, each specializing in one small aspect of antimatter creation and storage. Some focus on the superconducting magnets that must be kept colder than deep space. Others work on the detection systems that track individual particles through their brief lives. The energy required to run these antimatter factories is enormous. The electricity consumed by CERN's particle accelerators could power a small city. Yet all this energy produces antimatter amounts so tiny they're invisible to the naked eye. It's like using the output of a power plant to create individual grains of the most precious sand. Every antiproton that scientists successfully capture and store represents a triumph of human ingenuity over the fundamental forces of nature. These particles cost more to create than their weight in diamonds, yet they weigh essentially nothing. They're more valuable than any treasure, yet they exist in quantities smaller than dust motes. The magnetic bottles that hold antimatter can preserve it for hours, days, even weeks if conditions remain perfect. During this time, scientists study their captive particles like astronomers studying distant stars. They measure how antimatter responds to gravity, wondering if it might fall upward instead of down. They examine how it absorbs and emits light, searching for tiny differences from ordinary matter. Sometimes the magnetic fields waver slightly, or electrical interference disturbs the delicate balance. When this happens, antiprotons escape their invisible prison and annihilate against the chamber walls. Sensitive detectors record these moments of destruction, measuring the gamma rays that carry away the energy of annihilation. The scientists who tend these antimatter machines develop an almost mystical relationship with their work. They speak of coaxing antiprotons into their traps, of nurturing magnetic fields like gardeners tending invisible flowers. Each successful capture of antimatter feels like a small miracle, a moment when human technology touches the fundamental forces that shape the universe. Creating antimatter also requires understanding the most subtle aspects of particle physics. Scientists must account for quantum effects that would seem like magic to earlier generations, particles that tunnel through barriers they shouldn't be able to cross, fields that exist in multiple states simultaneously until the moment they're observed. The underground laboratories where this work happens are temples of precision, where temperature is controlled to thousandths of a degree and vibrations are dampened to prevent any disturbance of the delicate antimatter storage systems. Even the footsteps of researchers walking through nearby corridors could potentially disturb experiments involving individual particles. Yet for all their complexity, these machines represent humanity's attempt to understand the most basic questions about existence. Why does the universe contain more matter than antimatter? How do the fundamental forces work at the smallest scales? What secrets are hidden in the quantum realm that exists beneath the world we can see and touch? The antimatter trapped in these magnetic bottles connects us to the earliest moments of the universe, when matter and antimatter existed in perfect balance before some unknown process tipped the cosmic scales. Each antiproton floating in its invisible prison carries within itself the memory of those first seconds after the Big Bang. As you rest tonight, these machines continue their patient work in underground chambers far from the quiet of your room. Magnetic fields as precisely shaped as crystal lattices hold particles that represent the universe's most perfect mirror, creatures of pure opposite that reveal truths about the nature of reality itself. The technology required to create and hold antimatter pushes human engineering to its absolute limits. Every component must work flawlessly, every system must maintain perfect stability, every measurement must be precise beyond anything required for any other human endeavor. But these earthbound efforts to capture antimatter pale beside the cosmic processes that create it naturally throughout the universe, in stellar cores and galactic centers where magnetic fields and energies dwarf anything humans can create. Yet even these magnificent machines, with all their precision and power, represent only the first tentative steps toward understanding antimatter's true potential, and perhaps one day harnessing it to carry human consciousness beyond the boundaries of our solar system. Look up at the stars visible through your window tonight. Each point of light represents a sun perhaps warmed by planets, some possibly harboring forms of life we can barely imagine. The nearest star beyond our sun lies so far away that light itself takes over 4 years to bridge the gap. Yet in the gentle glow of antimatter's promise, these cosmic distances might one day seem as crossable as ancient oceans once did to sailing ships. Imagine a spacecraft unlike any that has ever flown. Instead of carrying tons of chemical fuel in massive tanks, it holds just a few grams of antimatter suspended in magnetic bottles smaller than coffee cups. The fuel weighs almost nothing, yet contains more energy than all the rockets that carried humans to the moon combined. When this antimatter meets its matter twin in the spacecraft's engine, both transform completely into light racing away at 300 million meters per second. This beam of pure energy pushes against the ship with perfect efficiency, accelerating it gradually toward speeds that would make our fastest rockets seem like drifting leaves. The beauty of antimatter propulsion lies not in sudden, violent acceleration, but in gentle, continuous push that builds velocity over months and years. Unlike chemical rockets that burn their fuel quickly and then coast, an antimatter ship could accelerate halfway to its destination, then turn around and decelerate for the remaining journey, arriving with the same careful precision it used to depart. A journey to Mars, which now takes 9 months of patient travel through the solar system, might become a 3-week adventure aboard an antimatter vessel. The moons of Jupiter, currently requiring years to reach, could welcome human visitors after journeys lasting just a few months. Even Pluto, at the edge of our solar system, might become accessible within a year's travel time. But the true magic of antimatter propulsion reveals itself when we consider journeys beyond our solar system entirely. Proxima Centauri, our nearest stellar neighbor, lies 25 trillion miles away. With current technology, reaching it would require spacecraft that could sustain human crews for thousands of generations. Children would be born, live their entire lives, and die aboard ships their great-great-grandparents had launched. An antimatter starship could change this cosmic perspective entirely. Accelerating continuously for half the journey, then decelerating for the remainder, such a craft could reach significant fractions of light speed. What were once generational voyages lasting millennia could become expeditions completed within human lifetimes, perhaps just a few decades to reach nearby stars. The engineering challenges of antimatter propulsion stretch human imagination like rubber bands pulled to their breaking point. The magnetic bottles that hold the fuel must remain perfectly stable throughout journeys lasting years or decades. Any failure that allows antimatter to contact the ship's hull would vaporize the entire vessel in a flash of gamma rays. The spacecraft's design would need to protect passengers from the radiation produced by matter-antimatter annihilation. The engine would require massive shielding, probably located far from the crew compartments and connected by long, lightweight booms. The ship might look more like a delicate flower than the robust rockets we're familiar with, all shielding and fuel storage at one end, crew habitat at the other, connected by stems of metal and composite materials. Navigation across interstellar distances presents challenges that dwarf anything faced by Earthbound explorers. The spacecraft would need to maintain perfect course accuracy across journeys lasting decades, threading through gravitational fields and avoiding debris fields that wouldn't be detected until the ship was almost upon them. A navigation error of just 1 degree could cause the vessel to miss its target star system entirely. The crew of an antimatter starship would live in a bubble of human civilization carrying them between worlds separated by distances beyond easy comprehension. They would watch Earth's sun fade to just another point of light among thousands, then gradually see their destination grow from a distant star into a blazing sun with its own family of worlds. Communication with Earth would become increasingly difficult as the ship traveled farther from home. Radio signals that once took minutes to cross the solar system would require years to bridge the growing gap between Earth and the starship. Eventually, the crew would be essentially on their own, carrying human knowledge and culture into the cosmic deep with no possibility of real-time guidance from home. Yet antimatter propulsion could also enable something even more ambitious than one-way colonization missions. With sufficient fuel and careful mission planning, antimatter starships might be able to return to Earth, bringing news and samples from other worlds. These round-trip journeys would take longer than human lifetimes, but they would be possible within the span of human history rather than geological time. The fuel requirements for interstellar antimatter missions remain staggering by current standards. A ship capable of reaching nearby stars might need hundreds of grams of antimatter, more than has ever been created by all of humanity's particle accelerators combined. Creating such amounts would require manufacturing techniques and energy sources far beyond anything we currently possess. Scientists dream of space-based antimatter factories powered by massive solar arrays or fusion reactors. These orbital facilities would spend decades accumulating the fuel necessary for a single interstellar mission, building up antimatter reserves gram by precious gram. The spacecraft themselves might be assembled in space, never touching planetary surfaces that could contaminate their delicate fuel systems. The psychological challenges of interstellar travel would be as demanding as the technical ones. Crew members would need to maintain mental health and social cohesion during journeys lasting decades, traveling through emptiness so vast that Earth and their destination would both appear as mere points of light. They would live their entire adult lives in the confined space of the ship, dependent on recycled air and artificial gravity. Yet for all these challenges, antimatter propulsion represents the first physically realistic path to the stars that human science has identified. Unlike science fiction concepts that require undiscovered physics or impossible engineering, antimatter rockets work according to principles we already understand. The challenges are enormous, but they're engineering problems rather than fundamental impossibilities. As you rest tonight under the same stars that once guided ancient navigators across Earth's oceans, consider that those distant suns might one day welcome human visitors carried on beams of pure light. The same force that powers the cosmic dance between matter and antimatter could become the gentle push that carries human consciousness beyond the boundaries of our solar system. The dream of reaching the stars connects us to our deepest nature as explorers and questioners. Since humans first looked up at the night sky, we've wondered what lies beyond the horizon of our world. Antimatter propulsion offers a bridge between that ancient curiosity and the possibility of actually touching other worlds. But perhaps the most profound aspect of antimatter isn't its potential as fuel for starships or source of limitless energy, but what it teaches us about the fundamental nature of existence itself, the elegant balance between creation and destruction that allows the universe to exist at all. Let your body settle completely now, releasing all tension as we approach the heart of antimatter's mystery. Throughout our gentle journey together, we've discovered something remarkable: the universe's most powerful force is also its most peaceful. The same process that could theoretically power starships also creates the softest light, racing away at the speed of dreams. Consider the beautiful contradictions that antimatter reveals about the nature of reality. The most destructive reaction possible, complete annihilation of matter, produces the purest form of creation, light itself. When particles meet their antimatter twins, they don't really destroy each other. Instead, they transform into something more fundamental, returning to the energy from which they originally came. This transformation follows the same gentle mathematics that governs how flowers turn sunlight into sugar, how your body converts food into warmth, how stars forge elements in their nuclear hearts. E=mc² isn't a formula for destruction, it's a recipe for the most elegant transformation possible: matter becoming energy, becoming light, becoming possibility. The paradoxes of antimatter extend beyond physics into philosophy. The most expensive substance ever created by human hands costs more than nations, yet weighs less than butterfly wings. The most dangerous material imaginable produces reactions so clean they leave behind nothing but gentle photons. The rarest particles in our corner of the universe were once as common as the atoms in your body. Antimatter teaches us that opposites aren't enemies, they're partners in a cosmic dance that has been unfolding since the first moment of time. Every electron orbiting every atom in your body has an antimatter twin somewhere in the quantum foam that underlies reality. These twins exist not to threaten their matter partners, but to complete them, to offer the possibility of perfect transformation when the time is right. The fact that antimatter is so rare in our everyday world isn't a flaw in the universe's design, it's a feature that makes complexity possible. If matter and antimatter existed in equal amounts throughout space, the constant annihilations would fill the cosmos with so much energy that atoms couldn't form stable bonds. Stars couldn't gather enough matter to ignite. Planets couldn't cool enough for chemistry to work its patient magic. Instead, the universe chose existence over nothingness by the smallest possible margin. One extra particle of matter for every billion antimatter particles allowed everything we see to come into being. Galaxies spinning in the cosmic dark, planets orbiting their stars, life learning to organize matter into increasingly complex forms, all of it exists because of an imbalance so tiny it barely tips the cosmic scales. This delicate asymmetry reminds us that existence itself rests on the finest of balances. The forces that shape atoms must be strong enough to hold particles together, yet weak enough to allow chemical reactions. The expansion of space must be fast enough to prevent cosmic collapse, yet slow enough to let structures form. Even the values of fundamental constants seem perfectly tuned to allow a universe where consciousness can emerge and contemplate its own existence. Antimatter embodies this principle of balanced opposites that runs through all of physics. Light behaves like both waves and particles. Quantum systems exist in multiple states until observed. Energy and matter transform into each other with mathematical precision. The universe operates not on rigid rules, but on elegant relationships between complementary aspects of a deeper reality. When scientists study antimatter in their underground laboratories, they're not just investigating exotic particles. They're exploring the fundamental question of why anything exists at all. Each antiproton suspended in its magnetic bottle carries within itself the memory of the universe's choice between existence and void, between something and nothing. The light produced when matter and antimatter meet isn't just energy, it's information. Those gamma rays carry messages about the deepest levels of reality, revealing how particles organize themselves, how forces interact, how the quantum world connects to the everyday world we experience through our senses. As you rest tonight, photons created by ancient matter-antimatter annihilations in distant stars are gently touching your skin. Some of the light reaching Earth tonight was born in stellar cores where ordinary matter occasionally meets tiny amounts of antimatter, contributing their perfect efficiency to the nuclear fires that have warmed our planet for billions of years. The antimatter story connects you to every scale of existence, from the quantum realm where virtual particles pop in and out of existence, to the cosmic scale where galaxies burn with the light of countless stellar furnaces. You are made of atoms forged in stars, cooled in the depths of space, organized by billions of years of chemistry and biology into the remarkable consciousness that can contemplate its own atomic structure. Antimatter reveals that the universe is far stranger and more beautiful than our everyday experience suggests. Reality operates on principles that seem impossible until we learn to see them correctly. Particles that shouldn't exist do exist. Reactions that should be violent produce the gentlest light. Processes that appear destructive are actually creative transformations. The antimatter falling gently from space, the positrons created in medical isotopes, the antiprotons trapped in magnetic bottles, all of these connect you to the fundamental creativity of the universe. They remind us that at the deepest level, nature operates through transformation rather than destruction, through balance rather than chaos, through elegant mathematical relationships rather than random chance. Understanding antimatter helps us appreciate both the power and the fragility of our existence. We live in a universe capable of perfect transformation, yet stable enough to allow the slow processes that build complexity. We exist because of the most delicate imbalance, yet that imbalance has proven strong enough to build galaxies and consciousness. The gentle paradox of antimatter, destructive yet creative, dangerous yet peaceful, rare yet fundamental, mirrors the paradox of existence itself. In a universe that could easily have remained empty, something extraordinary happened. Matter learned to organize itself. Life learned to contemplate its origins. Consciousness learned to appreciate beauty. Tonight, as you drift toward the gentle transformation we call sleep, carry with you the knowledge that you're part of this cosmic story. The same forces that govern antimatter annihilation also power the metabolism in your cells, the thoughts in your mind, the dreams that will soon carry you into realms of pure possibility. In understanding antimatter, we glimpse something profound about the nature of reality itself, that existence is not a battle between opposing forces, but a dance between complementary aspects of a deeper unity that expresses itself through endless creativity and transformation.